So this next lesson is on solving radical equations, and we've been practicing simplifying radicals and radical expressions, and then we'll be using that to solve equations that involve radicals. So we're going to look at these equations here. We have the square root of x equals 5. And as always, algebra is algebra. Whatever you do to one side, you do to the other side. And you always do the inverse, all right? I want x by itself, so I'm going to do the inverse function of the square root, all right? And so that would be squared, all right? Squaring something. So I'm going to take this side and I'm going to square it, and I'm going to take this side and I'm going to square it, all right? And then if I square, because remember this is like a square, there's nothing there, that's a square root. And so these are the inverses. So what I have is x equals, and then 5 squared is 25. All right? Very good. And then now I'm going to do the same thing here. You always try to isolate your variable, right? So, and the variable is inside this radical. So I'm going to isolate the radical. I'm going to get it by itself. So again, do the inverse of plus 3 would be minus 3 on both sides. So I get, now that is going to be 0. So I have the square root of 2x equals 7. All right. Now I want to get rid of the radical because my x is underneath the radical. Okay. So now again, I'm going to do the inverse. That is a square root. So I'm going to square this whole thing, all right, and then those go away, and I get 2x all by itself. If I square this side, I have to square this side. All right, so 2x is going to be equal to 7 squared. 7 times 7, which is 49. All right, and then now I'm going to keep going because I want x by itself. This is 2 times x, so again, I'm going to do the inverse, so I get 2 divided by 2 is 1. And then I've got to divide this side by 2. All right. And so my final answer is I get x equals, and it would be 49 halves. Okay. Remember, that's the identity property. 1 times x is x. Okay. And that is my final answer. I have x by itself. And then over here, I'm going to do the same thing, all right? I want to get this x by itself. Well, it's inside a radical, so I'm going to get the radical by itself. And I've got to peel off the layers that are furthest apart first. So I'm going to start with the minus 4, right? And I'm going to do the opposite, so I'm going to add 4 to both sides. And then what's left? That's 0, negative 4 plus 4, so I have 4 times the square root of 3x equals 8 plus 4 is 12. Okay, I'm going from equation to equation to equation. And then now I have 4 times this radical. All right, so I want to get rid of the 4, and it's 4 times that. So I'm going to divide this by 4. 4 divided by 4 is 1. And 1 times something is that something. That's the identity property. And then 12 divided by 4 is 3. Okay, so I am getting closer. I've isolated the radical. Now I want to get rid of the radical. Again, those are inverses. What I do to that side, I have to do to this side. So what is left is 3x equals 3 times 3 is 9. All right, and then finally, I almost have the x by itself. I'm going to divide by 3, divide by 3, and so I get x equals 3 as my solution. These are my solutions. Okay. Now, what I'm going to do is check for an extraneous root. Okay. Extraneous root means it's extra. All right, it actually made all these equations true, but it doesn't make the original equation true. Since I squared both sides, I can get something, a number, a value for x that is going to make this last equation true, but not the first equation. So you have to check it out using your store function. So you go and put, for the first one, I got x equals 5. So I'm going to substitute back into my equation and my original equation and see if it makes it true. And if it makes the original equation true, then it's not an extraneous root. All right, so my original equation was the square root of x, which I solved to get 25. All right, well, that is 5. Okay, so if I put, I go back to the original equation, substitute in 25 and for x, and that does equal 5. All right, I get 5 equals 5. So that is not an extraneous solution. And now I'll go to the next one, 49 halves. Okay, and so I'm going to use my store function. So I'm going to do 40, and I want a fraction. So I'm going to do alpha y equals, enter, and I'll do 49 divided by 2. That was my solution, and then I'm going to store that into x. Okay, and I'll hit enter. So my calculator knows that value of x. And then now I'm just going to type out my original equation, which was the square root of 2x. And I'm going to arrow over, because I don't want this part underneath the radical, plus 3. All right, that was not under the radical. And that is supposed to equal 10. So I'm going to do math, I'm going to do second math equals 10. Okay, so square root 2, that's my original equation, because it has an equal sign. So that's my equation, and I'm going to see if that equals 10. And it says 1. 1 means yes. 1 means true. Yes, this does equal 10. Okay? If I wanted to, I could go up here and just type the expression on the left-hand side, and see what that equals, and then it would tell me, oh, that is equal to 10, and then I could look on my paper, and yeah, it's supposed to equal 10. So you could do it either way to check, but that is not extraneous. Those are actual solutions, okay? They check out. And then now I'll go to my other one, x equals 3. All right, so I'll do 3, store x, enter. So my calculator knows what x is, and then I'm going to type out the original equation. So I'm going to say 4 radical 3x. I'm going to arrow over because that's all that is under the radical, and the minus 4 is outside of the radical. Okay, and then I can hit enter to see if that equals 8, or if I want, I can go up here and hit and set the whole thing, do second math, and set the whole thing equal to 8, and see if that's true. Yep, that is true. So those are not extraneous solutions, okay? So we'll go ahead and do these next two and see if they will have an extraneous solution. All right, I'm just going to erase so it's not overlapping there. So again, I have the square root of x plus 1, and I have this plus 2 sticking out, and minus 4. So I want to isolate my radical because that's where my x is. So I'm going to subtract 2 from both sides. Right, that's one side, that's the other side. That is 0. So I am left with the square root of x plus 1, and that is all under the radical. And then I have 4 minus 2 over here. And I'm going to write equals. I'm going from equation to equation. Okay, now my x is underneath the radical, so I need to get rid of the radical. So I'm going to do the inverse on both sides. So the whole thing comes out, so x plus 1 equals 4. 2 times 2 is 4. Okay. and then now I will subtract 1 from both sides, so I get x equals 3 for that one. Okay. And then over here, oh, I have square root on both sides. It's supposed to be a square root. These are square roots. All right. So then I have x's on both sides. Well, no worries. I'm first going to get rid of the square roots. So I square both sides, right? And so I get x minus 15 is equal to x. Okay, and then now I'm going to get x on one side and the numbers on the other side. So I'm going to go ahead and do minus x here, minus x here. X minus x is 0. So I have negative 15 equals 0. So what does that mean? Can that ever be true? No. Right? They're not equal. It's not equal to 0. So this would be no solution. All right, there's no value of x that you could substitute in that would make that equation true. All right, and then let's see if this one is a solution or if it's extraneous. So I'm going to store 3 into x. So I'm going to do 3, store x, and I'll hit enter. And then I'm going to type out the original equation. You go back to where you started. So that would be second. And then I've got square root of x plus 1, and that was all under the radical. So then I'm going to arrow over so that the next part, the plus 2, is not under the radical. All right. And then I'll hit enter. And is that equal to 4? Yes, it is. So that is not extraneous. That actually is a root. And again, if you wanted to, you could type the whole thing and then do second math equals 4 and hit enter, and that does make it true. 1 is true. Okay? So, very good. Now we'll go to the next page and practice some more. All right? So remember we said that if you have a radical, you can convert it to a rational exponent. Okay? A radical can be written as a rational exponent always. Okay, and so you can do the procedure for solving for that equation though is the same. So sometimes some people like to convert their here's my rational expression. Some people like to convert that to a radical and then solve it like we were doing. All right. So for example, I would say 14 equals 5 plus, and then I'll say the square root of 7b plus 11, right? Because 1/2 power is 1 and then the square root, right? 1 here and then square root here, but neither one of those, I don't have to put either one of those. All right, 1/2 power means square root. So this equation with the rational exponent is the same as this equation with the radical. All right, and then I would just solve it by, just like I did, you know, I want to isolate the radical because there's where my variable is. So I'm going to get rid of this 5 because it is the furthest away. All right, so I'm going to subtract it, and I get 9 equals the square root of 7b plus 11. Now I have the radical isolated, okay? And so now I'm going to get rid of it, right? There's nothing else around it, so now I'm going to get rid of it by doing the inverse there. I'm going to square both sides, and so I get 81, because 9 squared is 9 times 9, which is 81. All right, and then this crosses out with that there. Those are inverses, and so I get everything underneath is not under a radical anymore. And so I have 7b plus 11 is equal to 81. And now I'm just trying to get b by itself, just like always. And I'm going to start with getting rid of the 11. So I have 7b equals 70. Okay. And then I'm going to divide by 7. Because 7 divided by 7 is 1, and by the identity property, 1 times b is b. And 70 divided by 7 is 10. So that is my solution. Okay? Now, so one thing you could do is if you have a rational exponent, you could always convert it to a radical. Right? I could also, instead of, because I ended up squaring both sides, I could also do this. I could say, okay, I'm going to subtract 5 from both sides, and I get 9 equals 7b plus 11 to the 1/2 power. Right? And that's the same thing as I did over here. Subtract 5. This is going to be the first step, no matter what. And then now I can say, okay, to get rid of this 1/2 power, I'm going to use my power of a power, right? And so I'm going to take this side, and I know that I'm going to if I multiply by the reciprocal, right? If I times this by 2 over 1, right? Then that is equal to 1. Half of 2 is 1. Right? These all cancel out, and so that would be 1 over here. So I'm going to multiply by the reciprocal. 2 over 1 is 2. So I'm squaring both sides. All right, for the same reason. That's the inverse. All right, and I would end up with the same next equation. 9 squared is 81. That's 9 times 9. And then this exponent is 1. Anything to the 1 power, right, is just that thing. So that's how we got rid of that exponent, by multiplying by the reciprocal, 2 over 1. Okay, and then I have the same equation, and so I'm going to get the same solution, which is 10. Right? Now, since I squared both sides, I should check and make sure that is not an extraneous solution. All right, so I take the 10. All right, so I'll take 10, and I will store it in x, or b, whatever, and then I'm going to put it back into the original equation, which is 14. I'll go ahead and write out the whole equation, second math. So 14 equals, I'm just going to write it exactly like it is on the paper, 5 plus parentheses 7x plus 11, close my parentheses, and then that was to the 1/2 power, so I'm going to use the caret, and then it's a fraction, so I'm going to use alpha y equals, enter, and that is the 1/2, oops, it's supposed to be just 1/2 power. I'm going to arrow over. All right, so that, and I'm going to check, that's the same equation, all right, that I had originally, and that makes it true. So it's not an extraneous solution, so that's a real solution, all right? So 10 is the answer there. All right, so now same thing here. I have something to the 1/2 power. All right, so I'm just going to take it to the second. I'm just going to do the reciprocal here, so I can, just like so basically I'm going to square both sides, right? I'm going to take this whole thing and square it, and I'm going to take this whole thing and square it. So it's, and then I'm going to use that power of a power rule, right? Power of a power, you multiply these together. All right, well 1/2 times 2 over 1 is 1. And anything to the 1 power, or first power, is just that thing. Okay? And that's, again, what makes it an inverse. So then I go here, and I've got a power of a power, so I multiply these together. That's 2 over 1. So the 2's cross out, and I've got something to the first power is just that something. Okay? So I got rid of the exponents, all right, by squaring both sides. And then now I want the ends on one side, right, n by itself. Okay, so I will go ahead and I have more over here. So, well, actually, I have a number here, so I'm going to go ahead and just subtract 3n from both sides. 2 minus 3 is -1, so I have -n. equals -4. Right? And so to make this be both sides the same, n's got to be 4. So I can divide by -1, divide by -1, right? And I get n equals 4 for my solution for that one. Okay, and then I would just check, I would go back to my original equation and check and make sure that it's not an extraneous solution. But we'll just go ahead and go to the next one so we can practice a little more. Oops. All right. So again, I have, I'm going to erase that so it's not in the way. All right. So we have a rational exponent, and there's our variable, which we're trying to get by itself, right? So we have to kind of peel away everything. And so you always start with what's farthest away, and that would be this -8. Although notice that it's times, right? -8 times that. So I'm going to divide. It looks like it might be maybe I would add 8, but since it's -8 times that, I'm going to divide by -8. All right, because these are inverses, times and multiplying. So now I have to do the same thing over here. Divide both sides by -8. And then what's left here is this k over 5. Oops.